Before we dive into optimizing lazy loading, let's add more lazy loading though. Let's make sure we also lazy load the shopping list and the off module. Of course, feel free to pause the video at this point and do it on your own. Thereafter, we'll do that together. Were you successful? In the end, we just replicate what we did for recipes. We add a new path, shopping list, and there we add load children and we point at the shopping list folder and there at the shopping list module without .ts and thereafter with shopping list module or whatever you named the class in that file. Now, important, if we have a look at that shopping list module here, whoops, this one. Again, make sure you're using the right name here in your route config. And of course, make sure that here you have a route setup where now you remove the path name and you have an empty path because the path name now went into this global route config where we set up lazy loading. Now let's replicate the same for off. Therefore, here the path should be off. And then we again use load children. We point at /off. Then at the off module without .ts, and then here at off module. And again, in the off module file, make sure the path is now just an empty path. With all of that in place, again, restart ngserve to be certain that these changes are picked up. Sometimes they can get lost if you don't restart the build process. And therefore now, with that all reset, go back into the app module, and just as before, make sure you remove the off module and the shopping list module here so that you're not eagerly loading that. Also remove the imports, save again to trigger a rebuild, and now let's wait for that to reload here in the application. This looks good. Now, you see that here the off module was loaded for me, which has only 10 kilobytes. The main module shrank to 54 kilobytes, which is great. Even the vendor module shrank a bit because some parts we previously imported there are now only imported by modules. So some parts of the Angular framework, like the forms module, are now only imported when that component that uses it is imported. And therefore now, when we do log in here, we go to recipes. Now the recipes module is coming in. If you click on shopping list, now the shopping list module is imported here. You see these imports popping up on the right, and that is lazy loading in action. And even though the effect is not that large in this app, we can see it, and of course it becomes bigger and bigger the bigger your application is. I mentioned a way of optimizing lazy loading, which itself of course is already an optimization. And with that I mean how the lazy loaded code is then loaded. Right now, we load code whenever we need it. So as soon as we visit /recipes, for example, after logging in, we bring in the recipes module. Now the downside of that, of course, is that this is downloaded and parsed just when we need it, leading to a very tiny delay in our application. We might not see that here because the module is small and the internet connection is fast. But the bigger the module and the slower the internet connection, or for example, if you temporarily have no internet connection, the longer that delay will be. And therefore, we can actually tell Angular to preload lazy loaded modules to avoid this delay. For this, we simply go to our root router module, so here where we configure our root routes, and you can pass a second argument to that. This is an object where you can configure that root router. And there you can set up a preloading strategy. And you can set this equal to preload all modules. The default is no preloading, you don't need to set this. But you can set this to preload all modules, which is simply and in the end a constant you need to import from @AngularRouter. Speaking of imports, you should remove the off component import, by the way, to optimize lazy loading as well. But with preload all modules imported and set here as a preloading strategy, you're telling Angular, well, generally, we're using lazy loading. So it will not put all that code into one bundle, it will split it as we saw it. But it will preload the bundles as soon as possible. So when we are on the off page, it will already preload recipes and shopping list so that these code bundles are already available when we need them. The advantage is that the initial download bundle still is kept small because there that code is not included, and therefore the initial loading phase is fast. But then when the user is browsing the page and therefore we have some idle time anyways, then we preload these additional code bundles to make sure that subsequent navigation requests are faster. So we're getting the best of both worlds, a fast initial load and thereafter fast subsequent loads. So with that preloading strategy set up, now if we reload this page here, you actually see something interesting. We of course see that, the main.js file and so on is loaded, but then we also see that here the recipes module is loaded and the shopping list module is loaded. And therefore now if I clear this all here, the network request output, you see no downloads of these modules here because they already were preloaded. Still, we had that smaller initial bundle, but we benefit from these code packages being there when we need them. And therefore, setting this preloading strategy is definitely worth a thought if you want to optimize lazy loading and you want to ensure that this goes as fast as possible. Now, you can even build your own preloading strategies here, where you could have more refined logic, for example, controlling that only certain routes should be preloaded, but that is beyond the scope of that course. Being aware of that preloading strategy is super important though, and that is how you could use it. Now that we learned about lazy loading, I can finally dive into what's special about services and modules. Because I mentioned that there is something special about that, but I could only explain it after diving into lazy loading because it's strongly related to that. I want to dive into where you can provide services and how that affects the instances of the services you're working with. Now, we can provide services in the app module. We can provide services in the app component or other components, if you remember the services section. There you also could add a provider's key to the component decorator. We can also load services or add services to providers of any eager loaded module. So in the recipes module before we added lazy loading, for example. And we're also, of course, able to add services to providers of lazy loaded modules. Of course, we can also provide services by adding the provided in root configuration in the add injectable decorator. And that would be recommended for all services that you planned on providing an app module otherwise. Now, when you provide a service in the app module or with provided in root in add injectable, the service is available application-wide. And with the service, I also mean the same instance of that service is available application-wide. You're always working with the same singleton instance. If you provide a service in a component, no matter if that's the app component or another component, then that service is only available for dependency injection inside of that component tree. And then all these components will again share the same instance, but we're talking only about that component tree. And if you provide the service in multiple sibling components of your application, then all these sibling component trees have access to the service, but each component tree has access to its own service instance. And I mentioned this and showed this in the services module of this course already. Now, the interesting thing is, if you do add a service to providers of an eager loaded module, you might think that that service is only available inside of that module, and that every module where you add a service to its providers has its own instance of that service. But actually, that's not the case. If a module is eager loaded, everything is bundled together initially, and therefore any services you add to providers in an eager loaded module, let's say the recipes module would be not lazy loaded but still eagerly loaded by importing it into the app module, any service added there will be available application-wide with one and the same instance. So adding a service to providers of an eagerly loaded module has the exact same effect as adding a service to providers of the app module or as adding provided in root in add injectable has. A huge difference can be seen if you add a service to providers of a lazy loaded module though. There, the service is only available in that loaded module and it gets its own instance. If you do provide a service both in the app module and in the lazy loaded module, then the service is of course available application-wide, but the lazy loaded module will get a separate instance, not the same instance you use in the rest of the app. Sometimes this can be desirable, but in other cases it might lead to a strange behavior where you would have expected to work with one and the same instance when you didn't. The reason for that is that when you do provide in the app module or in add injectable, you use the so-called root injector, so the root dependency injection mechanism of Angular. When you do provide it in a component, you use the component-specific injector, which is not the root injector, and therefore not the entire application has access to that. In an eagerly loaded module, again, the root injector is used automatically. With a lazy loaded module, a separate child injector is created by Angular for that module, and therefore that module has its own instance of that service. Therefore, the default should be that you use the app module or, again, provided in root in add injectable. You, of course, might have scenarios where a component tree needs its own service. For example, if that component tree somehow has a service that only matters for these components and doesn't matter application-wide, then there is no need to provide the service application-wide. You can instead provide it in that component. Eagerly loaded modules should pretty much never provide services. You should avoid this because the effect is the same as in the app module, but it's kind of unexpected and it's harder to detect services there, and therefore other developers diving into your code might look for a certain service, might look for it in the app module, not find it there, and therefore be confused whether this service is now intended to be available to the entire app or only to that module. Now, in a lazy loaded module, you can of course add a service to providers, but only do this if you deliberately want to have a separate instance of that service there. Otherwise, you can have strange bugs. So as a rule, generally you want to ensure that services are always available application-wide by using add injectable provided in root or by adding them to providers in the app module, unless you have a strong reason for adding them only in a component tree or in a lazy loaded module. Never add services in an eager loaded module. Now let's see that in practice.